Hi, in this video, I'm going to demonstrate a small Kafka-based event-driven system called Kafka Orders Event-Driven Demo. The idea is to simulate an e-commerce order stream, process it in real time with Kafka, handle transient errors using retries and a dead letter queue, and visualize everything in a React and Tailwind dashboard. At a high level, the system has three main parts. The first, there's a producer that continuously generates random order events. Each order has an order ID, a product name, and a price. So the producer serializes each order using an Avro schema and publishes it to a Kafka topic called orders. Second, there is a consumer, an API service. This service subscribes to the orders topic, deserializes each message from Avro, applies some business logic, and maintaining running averages both overall and per product. It also incompletes retry logic for transient failures and sends unprocessable message to a dead letter topic called orders DLQ. The same service exposes a simple REST API on port 4000 to expose the metrics and recent DLQ events. And finally, there is a front-end dashboard built with Vite, React, and Tailwind CSS. The dashboard pulls the backend every second and shows the total number of process orders, the overall average price for product statistics, and any recent dead letter queue entries. So, before running the application, the Kafka must be up and running. In this environment, Kafka is started using Docker Compose with Zookeeper and single Kafka broker export on localhost 9092. The topic orders and order DLQ are already created, so the producer and consumer can connect immediately. First, the backend consumer and API service are started. In the backend folder, the command npm run consumer is executed. This connects to Kafka, subscribe to the orders topic, and start the Express server on port 4000. In the logs, it is possible to see the consumer joining the group and send a message confirming that the Metrics API is listening on HTTP localhost 4000. And next, the producer is started with the npm run producer. The producer generates a new random order every couple of seconds and serializes it using Avro and publishes it to the orders topic. The terminal shows the each produced order with its ID, product, and price. As soon as the producer sends messages, the consumer terminal starts processing them. Each successful message shows a log line with the order ID, product, and the price, followed by the current running averages. The consumer maintains an overall total count and average price and product count and average. Occasionally, the consumer simulates transient processing errors. When that happens, it logs a retry attempt and waits for a short backoff period before trying again. If the error persists for 3 attempts, the message is considered failed and is sent to the order DLQ topic along with an error reason. These DLQ events are also recorded in memory so that they can be displayed easily in the UI. Now the frontend is started by moving into the frontend folder and running npm run dev. So Vite launches the development server and the dashboard can be opened at localhost 5173. On the dashboard, the total orders card shows the number of orders processed so far. The overall average price card shows the running average across all orders. The per product averages table breaks this down further, showing a row for each product with its count and average price. As a new message arrives, these numbers update in real time because the React app holds the metrics endpoint every second. At the bottom, the recent DLQ events table lists any orders that failed processing even after retries. For each entry, it displays the time, the order ID if available, and the error reason. This makes it easy to see that the retry and dead letter handling logic is working expected. So in summary, this project demonstrates a complete end-to-end event-driven architecture using Kafka, Node.js, and React. It shows how orders can be streamed through Kafka, processed with retries and dead letter handling, and monitored in real time through a simple dashboard. This pattern can be extended to more complex domains such as payment processing, IoT, telemetry, or real-time analytics, but the core ideas, event streaming, scheme-based messages, running aggregation, and DLQ remain the same. So thanks for watching.